How's it going, everyone? My name is CJ, and I'm going to take you guys through our capstone project for this semester. So before we get into the hardware itself, I'm going to give you guys a little background information on our sponsor and why exactly we did this project. So our sponsor is Hopkins Applied Physics Laboratory. They're a research team that helps support the air and missile defense sector for our military. They tasked us with building a deployable missile fin simulator. So they wanted to use this to help their research so they could better understand how the friction, the mass, and the spring components actually impact the deploy time of the missile fin. And this is very important because if the missile fins don't actually deploy when they're launched in about 1/8 of a second, this can cause an inaccurate missile flight because the fins are one of the main components that actually guides the missile to its target. So now let's get into the hardware. This was our alpha prototype. So basically we wanted to demonstrate how the missile fin would actually deploy. So the missile fins on the ship, they actually start out bent inside the canister. And when they're launched up, they immediately fly open. So that's what we were trying to demonstrate with this model. So we just made it out of wood because it was very basic and easy to manufacture. Okay, so this right here was our second prototype, our beta prototype. We manufactured this one out of 4140 steel. This wasn't exactly the material that you would see on a missile, but it was more realistic. So this model was basically our practice round in manufacturing out of steel. So we were able to demonstrate the flipping mechanism on this prototype, and we were actually able to test out the strength of it. We actually found out that it was actually a little bit weaker than we had anticipated. So we did learn a lot from this prototype, and then we carried that through into the final prototype.
So here's our final prototype. I wanted you guys to get a better view of all the parts that went into this. So this is the outer panel that flips open when the missile fin is deployed. These rods are where the rotation comes from the outer panel. These brackets on the outside actually help the system withstand some of the forces that's coming from this panel. And the inner panel kind of acts as the base of the system. And this block is for the locking pin that actually sets the fin in place once it's deployed.
And finally, this is our electronic portion of the design. So this is all the electric wiring right here, but basically they map to these two switches here, and these switches will give us the deploy time and angle of the fin. So when the fin comes across and trips the wire, it'll set off the sensor and give us the data. So yeah, that's the end of the presentation. I hope you guys enjoyed the video.